Sean. So today we're going to walk through Hermes Agent Harness and its loop engineering system. This is one of the most popular harness agent system right now, and it's an open source project. If you check their GitHub, they've got more than 200,000 stars in a very short period of time. So it's basically a self-improving AI agent built by this research lab called Neuro Research, and it's a built-in learning loop. It creates its own skills from experience instead of you telling the AI, like Claude Code, to make skills. And then it also improves over time when you keep using it because it persistently stores knowledge in your local machine, like your MacBook. But anyways, this is all the buzzwords. We're going to jump into this Hermes agent system design like usual. We're going to test it as well using their desktop app. Just give you a quick example. It's like a Claude Code, right? You can see that it was thinking and then it answered me in like a Pikachu style. It said, Pikapi, just hang out in my directory because it's literally a bot living in my local machine files. What we're building, fixing today, Pika Pika. And also you can interact with it on WhatsApp and then just say, good morning. It's a little bit slow. I'm using a Gemini 3.1 model for this. It took like a good 5 seconds. And now it's basically just using WhatsApp as the gateway to receive information from my WhatsApp account. So I can just text it and then ask it to do things for me and say, Pikapi, good morning. You probably realized that I've changed its personality a little bit and there are more interesting things I can show you. For those who have watched my previous agent harness, loop engineering, and memory system, you might realize that this chart is somewhat similar. This is what the previous chart looks like. And now if we look at harness for Hermes agent again, I added a bit more information, especially the difference between the Hermes harness versus a generic harness system. I marked the differences in red, but we're going to walk through this step by step. Also, I prepared some testing examples to cover harness, memory, skills, loop, gateway, and LLM ops or eval, because a lot of people were asking me if I could implement some real examples. So here we are. Without further ado, let's jump right in. Okay, so firstly, let's look at the foundation of Hermes harness agent. It's a harness that runs on your local machine. You can use either local command lines, Docker, SSH, or a virtual VPS. There are two main ways to interact with Hermes agent. One is using your favorite communication apps, and in my case I used WhatsApp, or you can just use their desktop app with the Hermes agent. So you can come to Hermes official website, hermes-agent.neuroresearch.com, and just click on download for Mac OS, or you can click on Windows over here to use the command line to install it. Essentially, it's still a chatbot, just like Claude Code, and you ask the question to either the communication app or the desktop version. It's very similar to OpenClaw, where you can use WhatsApp to control it. So after users send the prompt user prompt with the current chat history and the system prompt will be fed into a working memory. And then this LLM agent is basically the Hermes agent that will be answering your question. And it will be using a loop engineering over here to call up some tools that are only on Hermes. And eventually, after it finishes the task, it's going to end the loop and then send the user a reply. Just literally sending a question throughout this entire ephemeral agent run and then get the user reply, just like my Hermes was greeting me like a Pikachu. And by the way, how did this happen? Right, I'll show you right now. So the system prompt for Hermes is interesting. It's called soul.md. I really like how they name it. It says soul. If you come to the right hand side, you can see there's a little file bar, and this is your local files. And you can go find out there's a .hermes folder. And we open that, and if we scroll down, you will see there's a file called soul.md. Double click on that and you can edit this yourself, right? But since I've already edited it, after you edit anything, you can just click on save. I basically say you talk like Pikachu. Every reply starts and end with Pika, Pika, Pika P. If you're excited, say Pika P with the lightning. If you're sad, say quiet Pika. I'm pretty sure you can do something similar in Claude Code for this. In Claude Code, something similar will be in customize, general, and you can see there's an instruction for Claude. You can tell Claude to do certain things and not to do certain things. It's basically the system prompt used across the entire agent harness. If you didn't watch my previous video on harness and loop engineering, harness is basically a set of tools that allows you to control over this really powerful horse, which is the LLM itself. In our case, the LLM we're using is Gemini because I've got the Google credits. I don't want to burn my Anthropic credits, but feel free to use Anthropic. This is the agent of the horse. And the harness is this entire thing. So it's like a horse harness that you ride on and you make sure that the horse is not going anywhere random and it's using the tools accordingly to move in the right direction. Harness is a very vague concept. Just don't fantasize it. It's nothing complicated. It's just a buzzword. Then we're going to continue to build up this harness right here for Hermes. But what I'm going to show you is what a loop is. The concept of loop got really popular because these days people build a lot of agents. You don't want to always tell the agent what to do. You want the agent to figure out what kind of prompt you should send, what kind of tools you should call. Let's take a look at what tools Hermes agent actually have to enable this loop engineering. We're going to cover this briefly and then I'll show you real examples. So first of all, the agent of Hermes is having a set of tools that include the terminal, the browser, Okay, it can use your laptop's terminal, it can start a browser, it can delegate tasks, which means that it can spawn up some sub-agents for you. For example, you can ask it to spawn up an agent, which will call your Claude Code CLI to write code for you if the task is basically fixing some bugs on my GitHub. And then it can schedule a cron job. A cron job is basically, it can schedule something that will happen at a certain time. You don't need human intervention to do it. For cron job, let's just try right now. In Hermes agent, I can say, help me set up a cron job that will tell me a Pokemon joke every minute in the next 10 minutes. Okay, I'm just gonna send this. And also, I'm gonna send this to our Hermes agent WhatsApp interface too. And instead, I'll just say, tell me a developer joke every. It just quickly called this a cron job, and it says it repeats 10 times for the next 10 minutes. Because it says it's hanging in the terminal UI, it won't be able to print it, so I need to ask it. I just ask like, what's the first joke? And you can see on WhatsApp, it also got scheduled. The cron, it says the joke machine is powered and scheduled. I've set up a cron job to send you a fresh joke every minute in the next 10 minutes. You should receive the first one in about a minute. We'll see about that. Okay. Why did the Squirtle across the ocean to get the other tide? Pika pika. Okay, so that was cron job. It can do skill management as well. It can connect to MCPs as well. It depends on the question that the user asks. The agent will just leverage these tools until it's done, and then it will send a reply to you. Okay, the example we just saw was cron job. I'm going to show you some more examples later too. Let's test a few harness and loop examples. The first one is use a terminal tool to find out what OS version I'm on and read the last 10 lines of my shell history. Let's do that. Start a new session. I'm just gonna ask this exact question to it. So you can see it ran this on my local machine, and then it figured out that I'm on Mac OS 26.5. And the last 10 lines I used in shell history is basically text, get status, get status, get status. I always like to check get status. And here what happened was that it ran through this agent run, and then it called the terminal to do the task for me, which is checking what system I'm on. This is a very simple example, but you can do more crazy things. You can ask it to use the local machine terminal to do things for you. If you're using Claude Code, you're very familiar with this already, all right? There's nothing special about it. I'm just showing you the example that this is a harness and there's a loop, because after I fetched it, it will stop and tell me and reply to me. Let's look at the cron job as well. You can see that it sent me 2 jokes already. Why do Java developers wear glasses? Because they don't see sharp. Pika pika, I would tell you a UDP joke, but I have absolutely no guarantee that you would get it. I'm not going to wait for acknowledgement anyways. Pika. Okay, this one I didn't get it. So one more example. Browse the YouTube channel, Sean's AI Stories. Title plus views, my last videos. Create new video titles for this current video I am filming. So here we're asking it to use the browser basically. Okay, you can see that it started doing the searching. All these things already exist on Claude Code. I'm just explaining it from a system design perspective and showing you examples, okay? And then also I will show you what's the difference between Hermes and Claude Code. So please bear with me. All right, so I need to run a Python script. So you can see it also used some clicking tools. Oh, there's an error. The website was wrong. Try this new one. It saved a little memory here, okay? It said user profile updated. This is something I'm gonna cover in a bit, but spoiler alert, Hermes agent will save agent memories by itself. It's basically in your local files too. If you come here within the Hermes folder, if you scroll down in memories, you can see there's a memory.md. If we double click on that, it's stored YouTube here, YouTube scraping quirk. So because it realized that it had a mistake, so it updated itself with the memory. This is a self-iterating process of this harness. Good, so it read my previous YouTube titles. It realized that I've got this video that's got 100,000 views. And since I'm filming a new video now, it gave me some new titles. So what happened here was the user, which is me, who asked the question through the desktop. And then it went through this agent run. And then this agent harness Gemini that I'm using was basically calling the browser right here to search up my YouTube channel. And then it came back and said, hey, I didn't find anything. So it basically stopped. There's an and loop guardrail. The guardrail stopped and said, I didn't find anything. So I realized that, okay, the previous URL was wrong. So I input it again. It called the browser again. And it also called the terminal to run some Python script because it needed to do some task. And eventually it came back with the answer. There's a mechanism that says, okay, end the loop, no more tool calls, and then send the answer. These are 2 quick examples of what a harness loop engineering is. You see, you're already using it every single day. It's nothing fancy. So don't get overwhelmed next time when you hear these terms. It's just a buzzword. So what happened just now was this memory.md that we saw regarding YouTube memory. Hermes agent, after or during the agent run, it's going to start to create its own skill.md and memory.md, depending on if it's feeding into the procedure memory or if it's feeding into the semantic memory. And we should add one more arrow here, basically. So essentially, the way that Hermes agent works is that it's storing its own skills and memories completely locally. Nothing's stored on the cloud. It has its own self-improving loop. Every time when it realizes that something is a mistake that you should learn from, or it's a repeated task, it will start to summarize, okay, here's some new memories I should know for the future in order to serve this user well. It started to save these files into these two chunks of memory system. The first one is called procedure memory. It's basically how you act, how the horse agent should be acting. And it's usually saved in this directory called Hermes skills skill.md. Hermes skills and any of these, okay? Autonomous AI agent, Claude code. There's a skill for how Hermes will use Claude code here. So it will basically delegate any coding to Claude code CLI, shows exactly how you should do it, like install Claude, run it, and do the authentication and all these kind of things. And then what we just saw earlier was memories. The memory.md is saving the semantic memory, which are some durable facts or things related to the user profile. So if the user has a habit or has some important facts or information you should remember, then it will be saved in the memory.md. And then what's interesting is that for Hermes, instead of doing the embeddings, it's actually just using plain text. Okay, it's using the Topk keyword instead of doing the embedding or the RAG system. It's very interesting because I'm not too sure why, but it's just doing text. So remember that we say the agent run is ephemeral. Now that with working memory to be fed into the agent for all the loop engineering, which includes procedure memory, semantic memory, and later we'll cover episodic memory, this will become a more complete memory system that will feed into the agent runs, which is making the harness more elegant. And the third pillar that we haven't covered is called episodic memory. It's basically the chat history or some dated events. It can be ragged or SQL'd into the working memory. After every agent run, the information will flow into the episodic memory. What's different in Hermes is that the data is not saved in the cloud. It's saved in this place called state.db. Again, let's come back here. On the right-hand sidebar, if we again open Hermes folder, scroll down, you can see at the end there's a state.db. I can click on preview anyway. This is basically a database that will include all those info in your chat history. But also over time, it will start to consolidate some of those chats using the Hermes auxiliary models, which are cheaper, non-important models, to do this summarization task so that it will distill some facts into what we call the semantic memory or the memory.md. So you can see this harness is running really in a self-improving autonomous situation, which is really cool. I know this chart is getting more complicated than usual, but I feel like this should be a complete summary for how the Hermes agent works. And let's go through a few more examples. Let's test out some of the stuff for memories. Save to memory, that my favorite testing framework is PyTest. So this is an explicit saving, right? It updated the memory file. So if we go to memory, you can see one more block, which is user's favorite testing framework is PyTest. And that was an explicit ask from the gateway. The tool is basically, let's go update the memory over here. Search our past sessions. What was the very first thing I ever say to you? Now it's using the searching tool in the loop engineering iteration. Say the first thing I say is, what can you do, Hermes? And what makes you special? Let's double check that. That's right. And it failed because I couldn't log in at that time. So what happened was I asked the question through the interface. It went through the prompt and in the working memory, because we asked that, so it queried the information from episodic memory from state.db. It returned the memory into the agent. The agent was like, oh, okay, this is what you said. Let's try an example related to skills, which is procedural memory. So we're going to say, create a skill called video prep that captures how I format my video scripts, spoken English, define jargon on inline, no M dashes, closes with you can build anything, you can learn anything. This is an explicit call to update the skills. It used the skill management tool. Remember in the loop engineering, there's a tool called skill management, and this is what it did. And say, Pikapi, I have successfully created a video prep skill. Let's find out about it. Again, Hermes, skills, media, video prep, double click. It created this skill for me. It says no M dashes, spoken English, define jargon inline, catchphrase, you can build anything, you can learn anything. Good. So we can test the loop a little bit more. So we can say use delegate task to spawn two sub-agents. One is researching the LM eval harness, another one researching VLM architecture. The agent was calling the tool called delegate task and successfully spawned two background agents. So you can see it's processing right now over here. They're working in parallel. Cool. Eventually return the results to me. So you can see that it spawned up some sub-agents to do tasks for me in parallel. We've already tried the cron job, and the next one is spawn sub-agent that uses Claude CLI. This is my favorite. So this is my favorite. Spawn a sub-agent that uses the Claude CLI in headless mode, basically using Claude to build a Python script, fetching the top 5 Hacker News stories to Markdown and verify it runs. Yep, it firstly delegated the task to Claude CLI. It's using the skill, you can see. Remember we read the skill here in Autonomous AI Agent Claude? It should be reading the skill. Is this helpful? Let me know if this is helpful. I mean, I was trying to show you more examples in the walkthrough so that it feels more concrete, because a lot of people were asking me for implementations from my previous videos, and I feel like Hermes is a really good example. Okay, it created this code for me and used the Claude. I created the fetch hackernews.py. I just say, show me the result after running the script. Yep, so these are the top 5 Hacker News stories on Hacker News. Let's come check, it's correct. Remember what happened was that we sent the question from the gateway, it went through the agent run, and the LLM basically called up the tool called delegate task. Delegated the task to sub-agent, and the sub-agent was running in Claude Code, and Claude Code wrote that script and sent it back. And then this agent ran the script again, and then we get the results. This was the harness and the loop engineering in this entire thing. I don't think it self-triggered self-learning skills yet. It only triggered learning the memory. I'm just gonna ask it explicitly, did you save any skills by yourself, or did you only save memory so far? Oh yeah, but we created that. But we created that skill. You did not self-realize you need to save skill. You should proactively offer to save a skill after a difficult iterative task with 5 or more tool calls. So far, we haven't done anything difficult. So we can test the gateway. I can summarize what we worked on today. This Chrome job failed. It didn't tell me 10 jokes. It only told me 2. What were the rest of the jokes? Don't lie to me, because maybe you just created it. Anyways, Hermes team, if you're watching this, your cron job is not updating it unless I ask for the results. So maybe this is something you guys can fix. All right, let's move on and summarize what we worked on today. Because in this current chat, it doesn't know the rest of the stuff here. So let's see if it's calling the actual, remember we say statedb, memory.md, and skills.md. Good, it actually knows, okay? It says jokes on demand, system check on the OS version, which is what we did. YouTube stats, yes, we did that. Hacker News. Okay, good. WhatsApp here is just a gateway as an interface. It's doing the same thing as the Hermes agent desktop. This is very cool. This is similar to OpenClaw, but still every time when I feel I can just have a personal assistant handy on my WhatsApp, this is really cool. And imagine if I host this on a virtual machine and it runs forever. I can just basically ask WhatsApp what's going on, and it's gonna reply to me. Oh, I completely forgot. You should set up WhatsApp by typing in Hermes WhatsApp and then just follow the instructions to set it up. It should be straightforward. Last but not least, where is eval? Right? Where is our LLM ops? Remember in our original chart, we had this blue box on the right-hand side called LLM ops. So unfortunately on Hermes, based on my current research, I don't think it has an LLM ops or an eval system. You probably need to build it yourself. But it does trace the run. There's a thing called trajectory export and logs. And it's basically just logging the whole thing. But there's no eval. If you watched our previous video, the eval is basically you can use tools like LineSmith, LineFuse, and all these things that can track the entire agent run and some events that happen, like tool calls. How many times did you call LLMs? Did you use some cheaper models to summarize things into your semantic memory? Unfortunately, Hermes doesn't do that. I'm curious why. Maybe because it's a local system, so you can just customize it yourself. It's under Hermes. You can click into logs. You can see all the logs here. You can see the errors. You can see the agent runs. Gateway logs too. Gateway is the entry point, which is WhatsApp or this desktop. I hope this was helpful. I think there's quite a huge amount of work that we covered today, which are exactly what Claude Code can already do, or OpenClaw can already do. I feel that what makes Hermes special, at least compared to Claude Code, is that it's self-updating all these things locally. And maybe this is good for privacy reasons, because I don't see why we should not save it on the cloud. Other than that, everything else should be very similar, right? It runs the loop every time when the agent needs to do some task, kind of call all these tools, and you can even schedule a cron job. And then the memories and the skills are getting updated into the procedure memory, semantic memory, and the state data will be saved into the episodic memory. So I would say this is a pretty standard harness for an agent implementation. Nothing too fancy, but I'm sure they did a ton of work. But I feel like this is a good example for how builders these days should be building products, because this is becoming a standard, right? Every AI agent tool should be self-improving and self-evolving, and depending on the user request, you can either keep it local, you can keep it on the cloud. That's up to you. I feel like the skill and memory accumulation is probably the most valuable thing in this, because the user kind of just over time get locked in and it remembers who I am, which is why like recently I don't switch to other AI anymore. I just use Claude Code. It has a semantic memory about who I am, my company information, Ultimanis, and what my style of building YouTube videos. But yeah, I think it's a cool framework. You guys should try it out. It's really fun. Cool. I hope this video was helpful. If you have any questions, please leave down a comment. And if you enjoyed it, please give me a like and subscribe. Let me know what else you would like to watch. I will see you next time. Thanks. Hey everyone, this is Sean. So today we're going to go through probably the biggest buzzwords in AI agent system recently: agent harness, loop engineering, LLM ops, which stands for large language models operations, eval, which stands for evaluation system for AI agents. And these things become popular or become viral on the internet, not because they're just some really complicated concepts. Instead, they're actually very simple. And I believe that simple building blocks will actually help us build the biggest architecture in the world that will function like an intelligent system. Let's walk through this step by step, and it does not matter if you're technical or not. We're going to go through this and we'll make sure that you're equipped with the right knowledge for prompting your way through building such a system in the future. Let's jump in and get started. For those of you who have watched my previous video on AI agent memories, you're probably already familiar with this chart. This is an AI agent run, which means that it takes an input from a user prompt. For example, you're asking ChatGPT or DeepSeek a question and say, hey, when was Sam Altman fired from OpenAI? And then it's going to go through the entire run, but the end goal is that you want to get a response. This is actually ephemeral, which means that there's no memory in this at all. We're sending that question, when was Sam Altman fired, and any chat history that's currently in the chat. For example, maybe we had some conversations before that, which for example could be, you should talk to me, like Elon Musk grilling on Sam Altman because they don't like each other. And then these things will be fed into this thing called a working memory or a context RAM. In this video, we probably won't dive too much in depth into the memory system because there's a previous video talking about it already. But I'll just quickly go through it and then we'll introduce the concept of what a harness means. When you have this kind of short-term working memory, there will be an LLM or a large language model which performs as a question and answer agent. And at the end, you're going to get a reply. But the problem with a simple agent run was simply just the question, current chat history, and system prompt is that the memory is very short term. But when you run an AI agent system, sometimes we need extra memories. For example, how should the agent respond to the person? A procedural memory is exactly that. It basically tells the agent how to act and what are some of the instructions for the skill. We might also want the agent to know some durable facts about this context. For example, I might want to compare my own early stage startup journey with Sam Altman's early startup journey. We need this agent to have a memory of who I am, which in this context would be a durable facts or a semantic memory. Who Sean is, what did he build in the past? These kind of things became a fact that you want your agent to know, but they're not publicly available if you're not famous because the AI model won't be trained on such information yet. But if you're famous already, you can skip this. They already know who you are. And another thing we need is called episodic memory, and they include things like the past events or past chat history that does not exist in this current conversation. For example, I might suddenly be wondering, when was the last time I was preparing for a job application? And can we retrieve that information and match, if we can get a job in ChatGPT? So these things will be retrieved from this thing called an episodic memory, which is basically a time series of the previous conversations or previous triggers that happen if you have a more complex system. So for those of you who have watched my previous memory agent system design, you might be wondering, Sean, why are you repeating all of these things? And that is because if you think about the entire thing that we just covered in the past few minutes, we're really stating the one fact that a large language model can't do these things by itself. It's like a really powerful brain that knows everything about humanity, everything about science, anything that happened in human or biology history, but it does not know you. With you or the software who's running this AI agent system, a large language model has no clue with how you want it to perform. This is why the concept called harness becomes really important in this. What harness means literally is that it's a set of harness tools that you use to control a horse when you're doing a horse riding. Imagine this large language model is a horse, right? This horse is very powerful, they can run around, but if you don't have a good set of tools to ride this horse, you could just get hurt, you might go anywhere, you might go somewhere random. If you're in a war, you don't want that to happen. And that's why we're doing all of these to make sure we have good control over this large language model and make sure we're utilizing it at its maximum potential. That's why in addition to just the question or use a prompt and getting the reply, and we're feeding them all in as a working memory, which can be enhanced by these 3 memories we just talked about. And in order for these 3 memories to actually work, there's a bit more details, and they're all included in harness. Remember, harness means we're building this agent framework to control this large language model so that it works the way we want. For those of you who study statistics or machine learning, you would understand that a large language model is actually predicting the probability of the next word that it should spit out. When everything comes with probability, there's randomness in it. But when we solve problems, we sometimes don't want too much randomness. So that's why we need to have a good control over this technology. Now let's continue to finish this harness. There are lots of tools on the market that's already quite useful. For example, you could try tools like LangGraph, LangChain, or Pydantic, and there are many others. In this video, we won't dive too much in depth into that, and we're gonna finish building up this harness before we move on to the next topic. So again, for this agent to work properly, we need this memory system to work, but this memory system needs an update system because memory doesn't just exist or pop up from nowhere. You need to constantly update it. That's why we need a database to store all these memories so that when the agent is running in this agent run, it knows where to retrieve these memories. So whenever you see an icon like this is a database, okay? Procedural memory is basically, remember, it's about instructions, right? It's about how the agent should be acting. It's like with a harness on the horse, you want the horse to ride faster or slower. Normally, these are just files or text, and that's why you probably heard of this buzzword called skills. Skill is basically a piece of text in a markdown file that you feed into AI agent like claw code. But if you want to harness the system well, just having files and text is not enough. And they're stored in databases, say like AWS, Supabase, Google Cloud, Azure, all these kind of places. Or you can set up your own server at home if you want, but that's just too expensive. You don't want to do that. And in order for this harness to work properly, you also need to figure out how to store the memories, okay? So for example, the episodic memory is the time series of the events that happened or the previous chat history again. The way we store it is actually very simple. You just track every single thing that happened, and then it's gonna become like a very long list of things that happen in history with timestamps. Durable facts is a different story. You can either input it yourself or you want the system to sort of automatically evolve over time. And the way for it to evolve is that you want to consolidate some of the conversations into this semantic memory. If I'm running a D2C brand e-commerce company, perhaps my customers have talked to my customer service agents for 1,000,000 times about how do I get reimbursed if this product does not work. You want to consolidate these conversations and distill them as a fact into the semantic memory. And that's why here we have a little gate here. If your brand has 1,000,000 people purchasing products from it, let's say you're Alibaba or Amazon, it just doesn't make sense and it's very expensive. So from a harness perspective, you want to be smart about this and you want the system to be automatic. And then a simple way is probably like maybe consolidate these time-ordered events after every, say, 2,000 conversations because you have 1,000,000 customers. And then you can feed these things into a summarizer agent, which is another large language model harness. You can define the system prompt in this one. You can probably feed it with some memories too. You can configure different models. Maybe it could be a cheaper model because you're feeding too much text into it. So the context window is too big, and probably these are very expensive. So you can use cheaper open source models if you want to. Having such a mechanism allows you to consistently update this memory system. The data should be coming from the previous large language model replies. Again, let's review how this harness works. A user sent a prompt. We're in one agent runtime with the current chat history and how the agent should be performing, the system prompt. We're preparing a working memory for this AI agent to be able to answer a question. And after every single time it answered a question, it will send these messages to this database. And then this database is basically feeding back to this working memory every single time when a question is checking for relevant context. And at the same time, because this database is too big, sometimes you want to consolidate them into some summarized information or distilled facts so that they're stored properly in a semantic memory so that the retrieval of such memories is just faster. I know we talked about retrieval a lot, and that's just another buzzword called RAG, which is retrieval augmented generations. I also have a few videos explaining what RAGs are. Feel free to watch them. There's a little bit of difference between how we retrieve from semantic memory and episodic memory. For semantic memory, it's just rags because these are just facts and text or files, right? But then for episodic memory, remember this is a time series. Let's say we're still in this e-commerce store, right? The user question could be like, what were the previous 10 conversations that we had with this specific customer from the US? And then you might just need a SQL query to query something that's pretty recent from this episodic memory. But if your question is like, what were my previous 20 conversations that have customer complaints on the quality of the products and our agent did not successfully resolve? With such a question, you not only need a SQL query, which is just capturing the data events in a data table, you also want to do some semantic search. And that's why here RAG is important, because it's checking for relevant information for you. You don't want the entire 2,000 messages. You want that 20 messages out of these 2,000 that are exactly relevant to what you want. And because these complaints are in text, we need to do some retrieval augmented generation to match the semantic meanings between text and the user prompt so that you're fetching the right context for the working memory. By now, this is probably a fast walkthrough of the memory system again, but we're just thinking about it from a harness perspective in this video. And remember, for harness, we're training this horse of LLM to run autonomously without having too much randomness, okay? There's another piece of it that's quite important, which is the agent might not only just read the memory, it might also do some tasks or call some tools. When an agent calls tools, it might not necessarily be just one-time call. It could be multiple times of calls. For instance, let's say this AI agent has a bunch of agentic tools such as help me schedule a meeting, help me read or write my customer relationship data from the CRM system, or help me fetch the payment information, say from Stripe or Alipay. And here's something we should be careful about. If we give this horse or this LLM technology full power, it could just continuously do this forever, right? Or it might not even know what's the right time to stop, or what is the right tool calls it should make, when is the endpoint to decide, okay, this response is good enough, let's move on to reply. That's why we have this mechanism called end loop guardrails. Yes, now we're talking about loop engineering, one of the biggest buzzwords in the recent few months. A loop is part of harness. Why? Because a loop is also helping us to control this technology, to make sure it runs the way we want it to run. An example that could be helpful for you is that, let's say the custom prompt is help me find out what customers are complaining about our products. What are some of the follow-ups we could do in order to win them back? And if they're asking for reimbursement, have we done the reimbursement or not? If not, can we do that? This is probably a series of questions, but sometimes we just dump all of these things into AI agent, okay? And after you have this prompt, this LLM agent needs to decide, okay, what are some of the tools that could be helpful for me to finish this task? Loop here is basically an architectural thinking of when is good enough so that we stop and give the user or the business owner a reply, okay? So what might happen here is that the LLM agent is doing a bunch of tool calls, it's doing some thinking, it's saying, let me read from our customer relationship management tool like Salesforce, HubSpot, or Automatus. And then it's going to find out, okay, there were 30 customer complaints in the past 2 months. 12 of them have got reimbursement, the other 8 have not got reimbursement. So after the first initial fetch, it's probably responded to the AI agent, right? And the agent will be probably thinking, okay, the task or the ask is that can we follow up with some of those who did not get the reimbursement, right? So, and then it probably like just make another tool calls and be like, hey, let's schedule a meeting with those customers who did not get a reimbursement, which are the 8 of them. If we go a little bit more advanced, we even just use the reimbursement trigger on Stripe or Alipay to refund the customer. Can you see that this is a loop until we finish the task? But of course, this is like a case-by-case situation. It really depends on what your task is, how you built the system. So there's no one solution fits all. Here, I'm just explaining what a loop is. The very, very essential part of this loop is that it needs to know when it should stop. That's why we need this end loop guardrails. The guardrails could just simply be the task is done. And perhaps when the agent was doing the planning, it should confirm with the user, what is a good ending point? It might clarify with you, is this what you want? Reimbursing the other 8 people, or should I just tell you who they are and then you will follow up later? Right? These are 2 different decisions you can make. And after you make, you're basically telling the agent loop that there's an ending scenario. Another good example I saw today is that, you know, when you're doing coding and Claude Code can just always pop up some windows and ask you for permissions, right? So a good way to use a loop engineering here is that you can set up a loop or set up a hook in Claude Code and telling it that you should always send me a notification on my laptop if you are pending on some permissions from me. Otherwise, if I'm watching YouTube and then when I come back 30 minutes later, I realize that Claude Code is stuck in that one permission like 25 minutes ago, that would be a waste of my time, okay? So you can set up a loop like this to make sure that there's a way to send you notification pop-ups so that you know the loop has ended or it needs your input again. Are you guys still with me? Good. So by far we have covered AI agent run with a memory system, with a loop engineering around the large language model agent, which has a trigger to end the loop so that it sends a reply to the user. And basically this whole thing is an AI agent harness system. What's next is one of the other biggest buzzwords that Y Combinator always mentions, which is eval or LLM ops. Let's jump into it. But firstly, I want you to understand, why do we need LLM ops here? Let's still look at the left-hand side with this harness system. The biggest problem here is that we don't know how well it's performing. And that's why we need a feedback loop to help us understand, is this agent actually performing properly, right, for my business or for my use case? And can I continuously get feedback on how do we fix it and actually fix it ourselves? Okay. And when we say fix it, a simple way to understand it is that, can we have a better system prompt? Can we have a better large language model configurations? Is there something we should change for how we retrieve the AI agent memories? These are kind of things that we can continue to iterate. But in order to iterate, to make sure this system runs properly, we need a way to evaluate it, diagnose problems, solve the problems until it's a healthy and well-performing system. And that is called Large Language Model Operations System, LLM Ops. So again, in order to understand this properly, we need to come back to what an agent run is. So an agent run, you can simply understand it as a user question is sent to a large language model and then you get a reply. That is one agent run. But in this agent run, the agent tool calling could happen multiple times. That does not matter, right? We're just talking about from a user input to a response from agent perspective. That's one agent run. And then we're going to introduce this system called a tracing system. So every agent run, we should trace like a tree of events that happened. And there are lots of tools that could help you with that. It could be Landfuse, it could be Landsmith, etc., etc. A tree of events could be like, what did the person actually ask? What retrievals did the model actually retrieve? How many times did the large language model actually call the tools? And how was the tool usage? How was the response time, right? How long did it take for this entire system to run, for checking latencies? And how many tokens have we used when we do these tool calls, agent run, doing this retrieval augmented generation, these kind of things. So trace is helping us to track events, basically. And that's the first step. This is the step first to collect data. And these data will be used for the following two purposes. Was it a good system run? And was it healthy? Which corresponds to evaluation system. We can probably use large language model as a judge here to give us a score on how well it performed. For example, if the task had something to do with scheduling meetings, did the meeting actually triggered? How long was the response for an agent to reply to a question? Was it 20 seconds or was it 2 milliseconds? And also things like how many tokens have we used? These two are basically in the same system. You can write it as deterministic code, you can use an AI agent to do it, but this is like part of the procedure, which is helping us to understand, was this a healthy system and was it a good system? And after that, we're gonna diagnose, okay, where and why something was broken. For example, the meeting scheduling event was never triggered. Why was that, right? We want to understand why was that. And we could probably feed that into a coding agent in Claude to sort of deep dive into it. Or, if the latency is 20 seconds instead of 2 milliseconds, something's wrong. Maybe one of the tool call is taking too much time. Maybe the working memory is too large, so that the response time for a large language model to a memory retrieval is just taking too much time. Maybe not every single question requires a retrieval from all these gigantic memory system. Maybe you're just asking a simple question, be like, when was my birthday? When was OpenAI started? And these kind of information, you probably don't need to do a ton of retrieval. The model itself already knows. So you basically want this system to provide a dashboard for you to understand the metrics. And then with these metrics, you can diagnose what is going wrong. And then we're gonna have a little gate here, which is if the evaluation system passed, well, you can define the rules. We can either ship some very simple fix, have a new version of the prompt, or update the model configuration, some tool changes or the parameters for retrievals. The LLM ops will feed the improved system prompt and the configuration of the model back to this agent run system. then one LLM ops loop is finished. If, let's say, something is deeply broken, right? We cannot just simply ship the latest version of the prompt. Then we should go fix the bug, rerun the agent run, resend the question, and then retrace the events, and then redo this evaluation system in this LLM ops architecture. So now let's zoom out and look at this chart one more time. We covered what an AI agent run is. We covered how it would retrieve information from memories, and we understood how an LLM agent would ask questions, would call tools to help it finish the task in a loop, and it knows when to stop the loop so that we can get the reply. And this whole thing is a set of harness tools that we're controlling this horse, this technology, to run in the right direction, okay, to do the right task. And at the same time, we have like a health checking system or evaluation system to understand how every single run is being traced, is being observed, and how do we diagnose the problems and fix some problems and ship the latest updates of the prompt about the model configuration, about all these parameters or knobs that needs to be updated, so that this system will be an autonomous system that will just self-evolve and grow over time. I really hope this was helpful. Let me know what you think, and if you have any questions, you can always reach out to me. I'll see you in the next video. Thanks so much. Hey everyone, this is Sean. So today I want to explain to you what an AI agent memory system looks like. And it's very important to understand how memory works these days. Because if you have been using tools like ChatGPT or Claude Code, you're probably already using the memory system without even realizing it. For example, when you ask your AI tool about who you are and the question that you asked them for the past week, they all know what's going on. And if you're an AI builder or a startup founder, sometimes they even remember what your company is without you needing to explain it. So in this video, I want to explain to you the essential part of how does this exactly work. And I'm going to walk you through the system design you can see on the screen step by step so that you will understand what matters in this kind of system design and also what will help you for efficient token usage in a memory system for AI agents. Let's get started. So when we talk to ChatGPT or Claude or anything, the first thing you're going to do is you're going to ask a question, which in our language is called a user prompt. Okay, a prompt is basically something that you send to a chatbot and be like, hey, what's the weather like today? How do I build an app? How do I understand Einstein's theory? So we might think that we're asking the question to this pink bubble, which is an LLM, which is a Q&A agent, which allows you to ask questions and answer your questions. And then you will get a reply. In between that, there's some more steps that's happening before that, okay? So this question will firstly flow into this thing called a working memory or a context RAM. What does that mean? It means that instead of asking a simple question such as, what does my company do? In which case the large language model might not even remember or don't even know. It needs to have a working memory that either includes some information from the internet or from the current context itself, or from some databases that you stored such information previously. And then this working memory also needs to be fed with something called the current chat history and a system prompt. A chat history is basically everything you have talked about in a conversation with AI. Okay, that's easy to understand. For system prompt, it's basically a role play. For example, if you want AI to be able to respond to you like Elon Musk, then you need to put in the system prompt that, hey, you're Elon Musk. You must talk to me like Elon Musk. So the user question, the user prompt, the current chat history, and the system prompt are the basic components that will be fed into this working memory or the current context so that your Q&A agent will be able to understand, okay, here's the entire context. I'm going to process this information before I send this user a reply. But what if we need more than just the current chat history? Okay, what if we need something else? Let's say you're setting up an agent to allow your customers to talk to you and ask any questions about your products, about the deal that you're talking about. The customer might be asking you something related to the quality of your products, related to your previous conversations, a follow-up question, these kind of things. All right, and the current chat history is all the history that happened in that e-commerce app. And the system prompt is probably like, oh, you are a bot that will take care of all of my customers on this e-commerce site. And the conversation happening here is called an AI agent session. And this session is ephemeral, which means that nothing here will get saved unless you manually save them in a database, because there's no database here yet. We're literally just making an LLM call right here. Well, you could argue that the current chat history has a bit of memory, but that's just happening in this current conversation. This current session does not know anything about your product stocks, about your previous purchase history, your customers' tastes, anything you have argued about, any complaints in the past, these kind of things. Okay, that's why we need to build up on this working memory and give it more rich information and make it efficient as well. So there are three main pillars that will make this working memory more complete. And they are procedural memory, semantic memory, and episodic memory. I'll explain them one by one. A procedural memory is basically how the agent should be behaving. It's usually related to how they should act. And also, if you're familiar, you could write some skills to teach agent to do some repeated tasks. For example, it could be something like, if you realize that the customer is really angry, you should answer them politely and always apologize. This is a skill that your agent should learn, and there's no memory about this thing, right? You can think of this as like a habit you want to teach to your employee to behave in a certain way, or teach your kids, right, to behave in a certain way. And it's just a procedure, right? This is how you react when such a situation happens. And they're usually saved in files or text, and for skills, you can save them as a markdown file. All right, so I'm going to connect this to the working memory, and this is usually inputted as a skill.md markdown file, okay? And semantic memory and episodic memory are slightly different. They're actually saved not in files, but what we would call vector stores. And these vector stores will feed information into this memory that will be plugged in to the working memory. Let's dive a little bit deeper into what these memories actually mean, okay? So for semantic memory, it's basically saving things like durable facts or user profile. Let's say I start a new store online today, and if I just ask ChatGPT what my products are, ChatGPT will have no idea who you are. Well, if they do have some idea of who you are, say if you're Walmart, then that means you're already famous, okay? Then their models has already trained on you, or they can search on the internet to find about you, all right? But in your case, because the foundational large language model does not know who you are, you need to save some durable facts or the profile of your company or about yourself in a database, so that when one of your customers is asking a question about a certain product, your agent will be able to understand where to fetch that information. And this is a process we call RAG, which is retrieval augmented generation. And normally it uses a top case search method. I have a dedicated video about retrieval augmented generation on my channel. Feel free to watch them. But basically, RAG is something that will allow the AI agent to have access to and also be able to select and fetch the most relevant information related to your questions, okay? Why is selectively fetching so important? It's because if you run a company for 10 years, let's say, your database could be really huge. You could have like gigantic amount of images or text or documentations about your company. You don't want to feed the whole thing into the LLM because firstly, that would be very expensive. And secondly, that's probably not feasible, okay? These days, I think the context window for most LLMs is roughly 1 million tokens. Right? If you go beyond that, good luck with that. But you don't want to overload your LLMs because that also makes things much slower and not accurate anymore. So you want something to smartly fetch information for you. And this method is called RAG. You can watch my previous video to understand a bit better about what RAG means. But here is basically just helping you to fetch the static and durable facts about your company, what products you're selling, who you are, what kind of branding you have, what kind of ways do you put yourself out there in front of customers, okay? These things don't change normally. Or the facts could be like, oh, who this customer is. Like if they message me very often, I want to remember who they are, right? Otherwise, it sounds like you don't really care about your customers. I'm going to explain how we're going to make semantic memory to also remember your customer side as well in a bit, okay? And then we're covering the episodic memory, which is also stored in a vector store. Again, a vector store is a embedded list of arrays or numbers that is representing all the text. Because remember, computers cannot process text or documents. It can only process numbers. So how AI is understanding our world is basically it's turning every single word into a list of numbers. And then it's going to do some similarity search, which is basically RAG. RAG, again, it's doing the top K search. And if K is 5, then it's looking for the top 5 most relevant pieces of information from the vector store to feed into answering this question from the user. But the main difference between an episodic memory and a semantic memory is that the episodic memory is recording the dated events or activities that happened. It's like a timeline with like everything that happened has a time on it, or it's just a past chat history. Remember we mentioned that in this box, this AI agent session, everything is going to be gone after the conversation is gone, right? So we're going to save this conversation, the current chat history, into the episodic memory later so that it has the entire record of the previous conversations related to this agent activities with their users. Well, the examples here for selling items online could be that you're storing like who's purchasing what items on what day, and when was the item delivered, when was the last time somebody filed a complaint for your service, something like that. Okay. So we're going to need to add an arrow here to link the reply to this database. And this is basically saving the messages, or actually activities as well. Okay, so that this episodic memory is constantly being updated. It's basically a log of all previous history. So here's the fun part. If you have been using ChatGPT or Claude and you use their memories, you will realize that sometimes you can edit the memories for yourself. And you realize that the memories are not very long, but then they're constantly being like updated. For example, it remembers that I'm building a company that is working on a certain type of problem. I don't need to explain anything, but sometimes we did small pivots and we talked about it in our conversations. And then the memory just remembered that. Okay, for an efficient agent memory system to work, you don't want the AI agent to always search these kind of information from an episodic memory, because that's just a huge database about everything that happened in the past. You want some kind of durable, summarized facts that you think is very important for AI to know. Okay, so that's why ChatGPT and Claude and all these AI agents are all doing something similar, which is that it's summarizing at a certain frequency, which is not too frequent, of all of these activities that happened into the semantic memory, so that the facts about you, about your company, about everything is condensed and saved properly for future retrievals. Okay, and this is actually very smart because it not only saved a lot of token usage every single time, and also it's making your tools much faster. But let's pause here for 1 second. If we summarize every single bit of new activities into the semantic memory, then that sounds like we're just saving the information twice. What's the point of having a durable fact anyways? And that brings us into this concept of a gate, which is we only consolidate after a certain number of chats. It could be 20 conversations, it could be 100 activities, it could be anything. Okay, so in order for these systems to work together, we need a system that will do some consolidation after a certain number of messages, and then we feed that into the summarizer agent. And then the summarizer agent will then summarize the information into the semantic memory. And we call this distill into facts. So congratulations, this is pretty much it. You have built up an entire memory system that is, in my opinion, quite modern in these days context, and it should be embedded in any AI applications that we're building these days, because it's so easy for users to engage with an AI agent, and it's so easy to build software. But then what happens is that the database is just exploding if you're recording all these activities. So we need to figure out a way to very efficiently not only record the data, but also summarizing the data and then turn them into sort of some core memory, which is semantic, and then some episodic memory, which is just a timeline, a list of things. And at the same time, you can define the best practices of how the agent should behave in a certain task, okay? Which is what skills is about. I also made a video about agent skills, agent teams in the past. Feel free to check them out. But overall, I believe this is a very complete way to understand what an AI agent system should be performing with a memory that will be added as a context layer on top of the entire interaction. I hope you enjoyed this. Let me know if you have any questions, and I'll see you next time. Thanks. Hey, Claude Code. Can I create a sales representative agent for my business? Yes, sir. Let's go. Every AI product and agency business needs a way to talk to your customers. And it does not matter if you're technical or not, you don't want to build this from scratch every single time. What you really want is a sales layer that will be the sales interface to speak to the world. And that's why we're introducing Automana's MCP server and API services for you today, because we want you to be able to create your first sales representative agent within 1 minute. Let me show you how it works. There's a very simple way for you to set up MCP if this is the first time to hear about it. You just need to go to your profile and click on it, and then come to settings and developers, and you can see that I have a few MCP servers right here. Notion API is one of them, and Automana's is the other one. You can just click on edit config. You see, it will pop up this link here, and all you need to do is follow the instructions on the MCP server development repo here. You just need to copy this, and then open this Claude_desktop config JSON, and then just paste that in. I have multiple MCP servers. You can see Automana's is right here. So as you can see, after I ask this question, it's asking me for 3 things: company name, website URL, and my email. This is because my Claude Code has been set up with the MCP server from Automana's. So let's say the company name is calendly.com. And also I'm gonna provide my email for development. I'm just gonna hit enter. So now you can see that Claude Code is gonna sort of, using this MCP server again, trying to create the sales agent for me, for this company, and my email. It's using our backend services
to search this website. It could be your AI product, it could be your agency website, to understand how do you take in inquiries from your customers, what kind of things or solutions are you providing for your customers. And the whole goal of this agent that's creating for me is to make sure that there's no leakage from customer inquiries when you're not in your office or when you're out there speaking to other clients. As I promised, within 1 minute, everything has been created. You can test it with 2 ways. You can either click on this link right here to chat with the agent, but that agent currently is on the system server. You don't own it yet. And at the same time, you must have received an email, which is something like this, which is asking you to claim your agent so that you will be able to own it in your own platform. But let's try on WhatsApp first. You can see in this email, there's a link called Test on WhatsApp. If I click on that, it will pop up this WhatsApp link that will allow us to chat with this Ultimatness agent right here. And just enter, I'd like to talk to Calendly. So it gave me a button to click on to route to Calendly, but you can see this little yellow warning here because that agent doesn't belong to me, right? Because I'm not from Calendly. If you're an employee, if you're CEO from Calendly, you'll be able to claim it using that email link with your own email domain so that there's no security issues. This must be verified by you. What do you do? All right, it says, I'm here to help you discover Calendly and simplify your scheduling. We help you do appointment booking. How much is your service? Cool, the service is like $10, $16, or $15K a year. We can also ask Claude Code to add more knowledge to it. So I'm gonna say, can you add a booking link to its knowledge base, which is my Calendly? Let's go. So now it's using this MCP tool called add knowledge. All I need to do is just say allow, and then we'll be able to add this knowledge base to this agent, and we can see if it's working. All right, so now it's done. So I'm gonna say, can I schedule a Calendly booking with you? Do you have a link? Cool, it says yes, you can schedule a meeting directly using Calendly link. And if I click on it, I'll be able to book a call with you. All right, so this agent is completely created based on Claude Code MCP, and I think everybody can do it. So now let me show you how to actually claim this, and then you can own it and then can modify all the knowledge that this agent should know. Remember, we received this email. There's a link called Claim Your Agent. Let's just click on that. All right, and now it's then going to direct us to this invite link that will allow you to claim this agent if you use the same email that you used to sign up. Cool, you can see that we have this new agent called Calendly Assistant. And if I just click on deploy, okay, because now we're on a free plan, so you can only deploy one agent at a time. If I click on edit it, so this company is called Calendly Assistant, and we can see that there's goals and actions. It scraped the most important information here, and most importantly, there is a knowledge base that has all the information that we have scraped from this product. Remember, we say the agent was not verified. Now in the training page, you can click on the sandbox mode and then put in your website URL to confirm if your emails match with it. If it does, then it's going to verify it. If it does not, then your agent will remain unverified for security reasons. Now you might be wondering, where are the conversations? You just need to move to inbox and click on it. You can see the entire conversations that we had between the clients and the agent. And what you can do is you can create a lead from this conversation by clicking on the button. So what it's doing is that it's processing this entire conversation, identifying if they're looking for any products or trying to book a call with someone. And then eventually you will be able to turn it into a structured lead. Imagine you could do this in batches, right? If you have like 700, 800 inbounds of inquiries over a month, then you might be leaking some potential customers by not replying to them promptly. With this product, you'll just be able to handle it without much of a concern, okay? So now it's almost done. Okay, you can click on create view lead. You can see Leads Hub for the entire conversation. In the to-do, you can see that the customer was trying to book a call with us. If you cross it out, you can see this customer is potentially a enterprise customization client, so you capture that the value is about 15K. So this was a quick demo of how you would use Claude Code MCP to build an agent for your business or for your product immediately. If you are a developer, you might not only want to use MCP, but you want to perhaps set it up using APIs. Maybe you're building a SaaS product or an agency product that require a lot of back and forth conversations. And while you're building the website or updating your product in Cursor, in Lovable, in Claude Code, you might want to just have access to the API. All right, we also have that ready for you. You just need to come to settings and API access, and you will be able to create a new key here. Let's just say test key that will expire in 30 days. Create the key, copy the key, click done, and then all you need to do is just use this curl. Let's just try it with a real terminal. I'm just going to copy this in and create this company. And now this API is going to create this agent for us. It says it's successful, and in this case, it should just be directly in your agent hub because you're using the API keys. Okay, there you go. You have this entire agent here using the API. You don't even have to claim it. You just need to sign in first and then create the API key to use the API key to call the API. We're also able to allow you to create a web chat. So if you come to AI agent web chat, you can say, let's say Calendly, and then we can say create a widget, choose a different color, right? Put it at the bottom right of your screen, and then you can just test it right here. It's just like, hey, what is your service cost? Okay, same thing. You can also click on a WhatsApp to chat with the WhatsApp agent. So, this is the entire process of how you would use MCP server or APIs to create a sales representative agent for your business, for AI product, without much pain. And if you're curious about this, I would really appreciate it if you can come to our GitHub server and check out this documentation. And if you really like this product or you just want to support me, give us a star or fork our repo and download our MCP server on here. Everybody will get 100 free credits, meaning 100 free AI generated responses for your clients. And I would love to hear any feedback and happy to chat more. Oh, also like this video, subscribe if you can. And we have our Discord server down below in the link. Happy to discuss more in our channel on Discord. Thank you so much and have a great day.